So the plan for this video is to showcase my arm movement versus a shared text document that we'll have, because this text will showcase what my arm is doing with like the numbers with it versus time. So we have our reference, pro, ground, and then we have further up my arm we have power, but you can't see it because it's on the one. But this program starts about 30 seconds, and if I move my arm, you can see the fact that the numbers will increase. But if I let my arm rest, it will drop down to about 1. But if I move my arm, it will spike up. Depending on how much it spikes up, it will do that. But yeah. Ooh. So I'm not moving my right arm, which I have electrodes attached to right now. Well, now I am because I'm showing. But if you move your arm, you have spikes in the data, which are done through our Arduino code that notices trends within the voltage reading of the electrodes here. And if you move more, it will spike more, and if you move less, it will have a lower level within it, because we just named our variable level because that's what we called it. But if I leave my arm flat against it, it will draw a flat line. But if I move my arm at all, it will spike up to the appropriate amount of how much I am moving my arm. Because if I actuate more of my muscles and like flex my muscles, it will like draw out more to it, and it will fluctuate based on how much I'm fluctuating my muscle. And that is read through the different electrodes. So we have power, ground, and then we have a reference one, which is comparing the difference between these two. So you can actually read the differences in the tenseness of my muscle. And that's that. Yeah. So because this is a square wave, when we turn on the system, it will fluctuate to where it cannot read. So in order to test the amperage, you have to be in digital, because it is a digital wave and not an analog wave, because it's a square wave. But it is set without any attachment or resistance to it. It's 300 milliamps, and a person has about 10k ohms, so this would be reading about 0.3 milliamps, which is far less than an EMS system should be outputting. And a system should output about 10 milliamps, but we could not get enough current to run that amount. But we do have enough for it to be very light when someone is connected to it.